I'm going to explain right triangle similarity to you in this video, and this is one of my favorites. I love right triangle similarity. So first thing, there is something called altitude on hypotenuse. So let me jot that down. So altitude on hypotenuse theorem. All right, now what this says is that if you have a right triangle and you draw an altitude from the right angle to the hypotenuse, you are going to create 3 similar right triangles. All right, and I know you're saying, what are you talking about? So here we go. And again, like I said, I love this. All right, so I'm using my little thing here. All right, so let's see how well I can do this. Let me do this over here. Actually, no, I'll do it in the middle. All right, so first off, I'm going to start with my thing here. And then, wow, look at this. Look, I am impressing myself here. Hold on. I am going to just trace my little cardboard thing here. Nice. All right, very good. Okay, so here's my right triangle right here. All right, so the altitude on hypotenuse theorem says that if I draw an altitude from the right angle to the hypotenuse, I am going to create 3 similar triangles, right triangles. All right, so first of all, altitude. Altitude is height. So this is the highest point. And whenever we measure height, I don't know about you, but I usually stand up straight. So we are going to drop a line right here that is going to make a right triangle or a right angle down there. And what we just made are 2 interior right triangles that are all similar to each other. So in this picture, I have 3 right triangles. I have the original one that I drew. I have this baby one over here, and then I have the middle size one right there. So one of the reasons why I love this is because I like to call this Mama Bear, Baby Bear, and Papa Bear, because I think that's a great way to remember what's happening in this picture here. All right, so here's the deal. When we have similar triangles or similar figures, we can write proportions and then solve for missing measurements. So what's going to happen here is you're going to get some measurements, but not all of them, and you're going to be asked to find a missing measurement. So this is what I want to show you, though, okay? All right, I'm going to do some color coding here. So let's use red, blue, and green. Okay, so Papa Bear is this whole big triangle here. So let's call, hold on, let me go back here a second. Let's say this is A, B, C, and we'll call that D, okay? All right, so Papa Bear is triangle ABC. All right, so we have triangle, A, B, C. So ABC is Papa Bear. Then we have Mama Bear, all right, and I'm going to do Mama Bear in red. Mama Bear, now if you paid attention to how I named Papa Bear, if we turn him like this, then you can see I did the hypotenuse to the right angle, so A, B, C. So when I name Mama Bear, I'm going to do her hypotenuse. So this is Mama Bear right here. So her hypotenuse to the right angle is ACD. So Mama Bear is ACD. All right, and then we have Baby Bear, and Baby Bear hypotenuse is CB to the right angle D. So CBD. So those are the 3 triangles that we're working with. So we can see that they have different measurements, but this is what I want you to focus on. Okay, so Papa Bear is actually, he has his hypotenuse. He is also, his longest side is Mama Bear's hypotenuse, and Papa Bear's shortest side is Baby Bear's hypotenuse. All right. Then I want you to notice that Mama Bear's short leg is Baby Bear's long leg, because that's going to come into play when we start doing some of the proportions. Okay, so first thing I like to do personally is to redraw the triangles so that you can see how they're related. So right under here, I am going to draw Papa Bear. So here's Papa Bear. Okay, he's the big triangle. Mama Bear is this one right over here. So Mama Bear, I'm going to make her right here. So she's a little bit smaller. I'm also going to turn them all going the correct direction. And then here is Baby Bear. He's this little one over here. But again, I'm going to draw them all going in the correct direction here. All right, so Papa Bear's right angle is angle C. His short leg is CB, and his long leg is AC. Okay, so this is short leg over here, this is long leg, and this one over here is the hypotenuse. All right, so when we look at Mama Bear, her right angle is at angle D. Her short leg is DC. Her long leg is AD. And her hypotenuse is AC. So there's long leg, and then here is her hypotenuse. All right, then we have Baby Bear. And Baby Bear's right angle is also angle D, because he shares that right angle with Mama Bear. Baby Bear's short leg is DB, and his long leg is CD, which then means CB is his hypotenuse. So here's his short leg, long leg, and hypotenuse. All right, so here's what happens. When we look at this setup here, Papa Bear's, I almost called him Daddy Pig, Papa Bear's short leg is Baby Bear's hypotenuse. So these two pieces are the same. So those two pieces are the same. So Baby Bear's longest side is Papa Bear's shortest side, which makes sense because he's the baby. Okay? Then we have Mama Bear here. And if we look, Mama Bear's longest side, which is her hypotenuse, so Mama Bear's hypotenuse is Papa Bear's longest side, which makes sense. His longest side is the flat side of the original right triangle that we cut with the altitude there. So what happens is Papa Bear is just three different hypotenuses, because there's his own. So Papa Bear is his hypotenuse, his long leg is Mama Bear's hypotenuse, and Papa Bear's short leg is Baby Bear's hypotenuse. All right, now there's a relationship between Mama Bear and Baby Bear, and that is that Baby Bear's long leg is Mama Bear's short leg. So Baby Bear's long leg is Mama Bear's short leg. All right, and that makes sense because the altitude that we dropped is what created Mama Bear and Baby Bear. So that side is in both triangles. it's the short side of mama bear, but the long leg of baby bear, which again makes sense because he's the baby. So baby bear is made up of mama bear's short leg and daddy bear's short leg. And then mama bear, her short leg is baby bear's long leg, and then her hypotenuse matches up with papa bear. Now, what you're going to see is that some don't necessarily have matching or corresponding sides, but don't forget that we're dealing with right triangles, and we can always use Pythagorean theorem if we need to. So don't forget about Pythagorean theorem. So I'm going to write that. Don't forget about Pythagorean theorem. Now, hopefully you know what I'm talking about because it's one of the most well-known theorems. So don't forget about Pythagorean theorem. And that says that a squared plus b squared equals c squared in a right triangle. So since we have right triangles, we know that a squared, which is the short leg, plus b squared, which is the long leg, will be the same as the hypotenuse, which is the longest side, squared. Okay, so here's how this works. So you're going to be given information, you're going to be given numbers, and then you're going to have to figure out the rest. So just to keep this picture as is, I'm going to write in pencil so that, and let me pull this out a little bit here so I have some more space. All right, so, and I'll show you why, just to keep from rewriting everything. All right, so here we go, example 1. All right, so let's say that BD is 8, and let's say that AD is 4. So let's find CD. All right, so first thing, here's your first lesson in geometry problems. Never drawn to scale. So just pretend that it makes sense. It doesn't at all, but just pretend it does. Okay, all right, so here's what we know. I'm going to go back up to this picture. I know that BD is 8, I know AD is 4, and I'm looking for this side, CD, right there. Okay, so I'm going to go to these 3 triangles. So BD is 8. So I'm going to look for BD, which could also be DB, and that is 8, which is right there. This happens to be a side that's not shared anywhere else on these triangles. All right, I also know that AD is 4, so AD is right here. That side also is not set up to match with any of the other sides of the triangles, but that's fine. So I have the short leg of baby bear, the long leg of mama bear, and what I'm looking for is CD, which is right here. But I notice by my color coding here that that appears somewhere else and it appears right there. So what this means is I have 2 sides of mama bear that correspond with 2 sides of baby bear. So that means that I can write a proportion and solve. All right, so the proportion, I'm going to do mama bear first. So I'm going to say long leg of mama bear over short leg of mama bear. So that's mama bear's long leg and short leg. Matches up with baby bear's long leg and mama bear's short leg. All right, so I did long leg, short leg of mama bear, long leg, short leg of baby bear. Obviously, we can't do anything here because we don't know what's happening there or happening there, so we're just going to have to multiply the diagonals. So if I multiply x times x, I'm going to go over here for space, that gives me x squared. If I multiply 4 times 8, that's 32. So that means x is the square root of 32, which then, if we think back to earlier this year, we can simplify this to be 16 and 2. So that means that the square root of 32 is 4 square root of 2. Now, if we want to, we can estimate that. Square root of 2 is around 1.4. So 4 times 1.4 would be approximately 5.6 if we were looking for an actual decimal answer. All right, so next example. I'm just going to use, like I said, the same picture. So I'm just going to go back up here and erase this. And let's see. All right. Okay. For this example, which I'm going to scoot down here for a second, and then we'll go back up. All right. So let's see. Example 2. Example 2. So this time I'm going to say that AC is 10 and AD is 4, and I want to find AB. All right. So AC is 10. AD is 4, and I want to find AB. All right, so now if we go back up here to our pictures, so AC is 10, AD is 4, and we're looking for AB. All right, again, I like mine separated here. So AC is 10, so here's AC, and I can tell by my color coding that that is found in another triangle, and the long leg of Papa Bear is the hypotenuse of Mama Bear. All right, I know that AD is 4, which is that one, and by my color coding, I know it's not related to anything else. And then I'm looking for AB, which is that one right there, which I know since that's Papa Bear's big leg, it's not related to anybody else. All right, so I have corresponding sides of 2 triangles, which tells me that I'm good to go in setting up a proportion. I have long leg and hypotenuse of Papa Bear and long leg hypotenuse of Mama Bear. So for my proportions, I'm going to do long leg and hypotenuse of Papa Bear, and then I'm going to do long leg and hypotenuse of Mama Bear. So long leg, hypotenuse of Papa Bear, long leg, hypotenuse of Mama Bear. All right, this one may not be as obvious at what you're multiplying by, so we can just go ahead and multiply diagonally. So 4x equals 100, which tells me that x is 25. So that means that side AB is 25. Okay, that'll give you a little bit of a start. Again, I like to use to kind of set myself up with the triangles. Some of you will be able to do without, which is great. Some of you are not there quite yet, which is fine. I like the visual anyways, and I've been doing this for a very long time. All right, good luck.